Welcome to the bilingual e-lecture series for diploma students. Today we are going to see some problems related to the mechanical properties of materials, which is covered in Unit 2 of Strength of Material subject for second year mechanical engineering students. Now let us go to the topic. A brass rod of 20 mm diameter and 1.5 meter long is subjected to an axial pull of 4 kN. Find the stress, strain and elongation of bar. Take E as 1 into 10 to the power 5 Newton per mm square. இதான் நம்ம கொடுத்திருக்க ப்ராப்ளம். என்ன சொல்லியிருக்காங்க? ஒரு brass rod. ஸோ ராடோட மெட்டீரியல் வந்து brass. Diameter of the rod வந்து 20 mm. Diameter of the rod is 20 mm. So the diameter of the rod D is equal to 20 mm. Then 1.5 meter long. What is meant by 1.5 meter long? Length of the rod is L. It is given by 1.5 meter and this is equal to 1500 mm. The rod is subjected to an axial pull of 4 kN. What does it mean? It means that the load P is equal to 4 kN. What is 4 kN? 1 kN is equal to 1000 Newton. So 4 kN is equal to 4000 Newton. 1 kN is equal to 1000 Newton. So 4 kN is equal to 4000 Newton. Young's modulus is given by E is equal to 1 into 10 to the power 5 Newton per mm square. So these are all the given data. What is required? Find the stress, strain and elongation of bar. So we go to find stress, strain and elongation of the bar. This is the given problem. Now we are going to solve this problem. First we will find the stress value. Stress is given by the formula P by A. What is P? Axial load divided by area resisting the applied load. Stress is given by load by area. What is load? Load is nothing but applied load. Here it is 4000. Here it is 4000 Newton divided by what is the area? Area is given by pi by 4 d square. Area is given by pi by 4 d square. So what is the value for d? D is 20. D is equal to 20. So area is going to be pi by 4 d square. This is given by pi by 4 into 20 square. So area is 314.159 mm square. 314.159 mm square. Okay. Now we go to substitute this value A in this formula. இதில் substitute பண்ணுறோம். அப்போ என்ன கிடைக்குது? Sigma is equal to 4000 divided by sigma is equal to 4000 divided by 314.159. So the result is going to be 12.73 Newton per mm square. 12.73 Newton per mm square. Okay. Next we are going to find the value for strain. What is strain? How to find the value of strain? Okay. So we know that Young's modulus E is given by stress by strain within the elastic limit. Young's modulus E is defined as the ratio of stress to strain within the elastic limit. So from this we can determine the strain. E is equal to sigma by Young's modulus, because Young's modulus is given in the problem as 1 into 10 to the power 5 Newton per mm square, and sigma, what is sigma? Sigma is the stress value just now we have determined. இப்போ கண்டுபிடிச்சோம் இல்லையா அந்த value. So strain is given by sigma by E 12.73 divided by Young's modulus 1 into 10 to the power 5. What is the value of strain? Strain is equal to 1.27 into 10 to the power minus 4. What is the unit for strain? Strain has no unit. Strain has no unit. Strain க்கு unit கிடையாது. Okay. Finally, we go to determine the elongation. What is the elongation? Elongation is given by del L. இதுக்கு பேர் என்ன சொல்றோம்? DEL. del அப்படின்னு சொல்றோம். ஓகேங்களா? del L. இந்த மாதிரி symbol. del L. Change in length. Elongation. How to find the elongation? Elongation எப்படி கண்டுபிடிக்கிறது? So we know the formula. Strain. What is strain? Strain is given by change in length to original length. What is the formula for strain? Strain is the ratio of change in length to original length. So strain is given by del L by L. Therefore del L is equal to strain into length. This is given by 1.27 into 10 to the power minus 4. Length is given in the problem itself. The length is given as 1.5 meter. This is going to be 1500 mm. So by multiplying these two values, we will get the elongation. Del L is equal to 0.191 mm. So the result is going to be stresses sigma is equal to 12.73 Newton per mm square. Strain E is equal to 1.27 into 10 to the power minus 4. No unit. Elongation del L is equal to 0.191 mm. So after solving the problem, you go to write the results also. So there are three phases in the problem, in solving the problem. First we go to write the given data, then to find. Given data, then to find. Second stage is solution. We go to solve all the required values one by one. Finally we go to express them as results. I think you understand the problem. It is a simple problem. Okay. Now we can move on to the next problem. An elastic rod 25 mm in diameter, 200 mm long, extends by 0.25 mm, under a tensile load of 40 kilonewton. Find the intensity of stress, strain and the elastic modulus. Find the intensity of stress, strain and the elastic modulus of the material for the rod. So what are the given data? Diameter of the rod is given as 25 mm, length is given as 200 mm, load is given by 40 kilonewton, this is equal to 40,000 Newton, and the change in length del L is given 0.25 mm. What is to be find out? We go to find stress, strain and elastic modulus or Young's modulus. These three data are required. Now we will go to the problem. How to solve the problem? First step is stress. Already we got discussed. What is stress? Stress is equal to load by area. What is area? Area is given by pi by 4 d square. So here the value of d is 25. So you substitute 25 and determine the area as 490.87 mm square. Now substitute this value of A here. Load is given in the problem itself. So we can calculate the value of sigma as 81.487 Newton per mm square. 81.487 Newton per mm square. Right. Next we go to find the strain value. What is strain? Strain is given by the ratio of change in length to original length. Change in length is given by 0.25. Original length of the rod is also given. So directly we can calculate the value of E as 1.25 into 10 to the power minus 3. 10 to the power minus 3. Along strain has no unit. Strain has no unit. Don't forget that one. Okay. The third step we go to find the elastic modulus. What is elastic modulus? Elastic modulus E is given by stress by strain. Stress by strain. What is the value of stress? We have determined 81.487 divided by strain. What is the value of strain? 1.25 into 10 to the power minus 3. So using the calculator we can easily determine the value as E is equal to 0.652 into 10 to the power 5 Newton per mm square. 0.652 into 10 to the power 5 Newton per mm square. Now we go to take down the results. We have to take down the results of all the values and we have to summarize them. Result, stress is equal to 81.487 Newton per mm square, strain 1.25 into 10 to the power minus 3, no unit, elastic modulus E 0.652 into 10 to the power 5 Newton per mm square. Now we are moving to the third problem. A cement concrete tube of 150 mm size crushes at a load of 337.5 kilonewton. Determine the working stress if the factor of safety is 3. Okay. It is a cement concrete cube of 150 mm size. Cube size is given, A is equal to 150 mm. What is cube? Cube means length is equal to breadth is equal to thickness. Length is equal to breadth is equal to thickness. So cube size A is given by 150 mm. Ultimate load or crushing load is given as 337.5 kilonewton. This is equal to 337,500 Newton. Then factor of safety is given as 3. So FOS, factor of safety is 3. Factor of safety is 3. We got to find the working stress. So we know the value of factor of safety. Factor of safety is nothing but ratio of ultimate stress to working stress. What is factor of safety? Factor of safety is given by ultimate ratio of ultimate stress to working stress. Okay. What is the value of ultimate stress? Ultimate stress is given by ultimate load or crushing load divided by area resisting the crushing load. So we can calculate the value of area. Here it is cube. So area A is going to be A square. This is going to be A into A. This is equal to 150 into 150 mm square. So this will be 22,500 mm square. So we can find the value of area. From this we can calculate the value of ultimate stress because the crushing load is given. Okay, crushing load is given. So the ultimate stress is going to be 15 Newton per mm square. Ultimate stress is 15 Newton per mm square. So we got to find the working stress. What is the working stress? What is the working stress? We know that factor of safety is ultimate stress by working stress. Therefore, working stress is equal to ultimate stress divided by factor of safety. We know the value of ultimate stress. Factor of safety is given in the problem. So we can substitute them 15 by 3 and the working stress is going to be 5 Newton per mm square. Working stress is going to be 5 Newton per mm square. We can take the working stress as 5 Newton per mm square. It is a simple problem using factor of safety. Hope you understand this problem. Okay. Now we are going to the next chapter, force required to punch a hole in a steel plate. How much force is required to punch a hole in a steel plate? So we are having a steel plate of thickness T. Okay, you assume the thickness of the plate is T. Thickness of the plate is T. Now we are going to make a hole. Now we are going to make a hole. How much force is required? How much force is required to make a hole of diameter D, on a sheet of thickness T. Okay. So the steel punch worked on to ultimate shear stress. How much force is required? Force required, F is given by force is equal to area resisting the shear force multiplied by ultimate shear stress. Ultimate shear stress. Force is given by area resisting the shear force, okay, multiplied by ultimate shear stress. What is the area? Here the area is going to be the total area resisting the shear punch. So we have to develop this hole. We have to develop this hole. we are going to make a hole in the steel plate of diameter d and thickness t. Clear? Now we are going to make a punch. This is the, you imagine, comparatively it is small, okay. You imagine you are going to make a punch to make the hole. So the area resisting will be, we have to develop this cylinder. What is a hole? Hole is nothing but yes, cylindrical shaped removal of material. Metal is removed in the form of a cylinder. So we have to develop the cylinder. Okay, the length of the cylinder is going to be its circumference. What is circumference? Pi into diameter. Pi into diameter. What is the thickness? Thickness is going to be t. So now we can calculate the area resisting the shear stress. Area resisting the shear stress is given by pi d, circumference, into t, thickness. What is pi? Pi is a constant. Pi is a constant. D can be represented as 2 into r also. Then it will become 2 pi r into t. D can be represented as 2r, 2 times the radius. Then this is going to be 2 pi r t. So what is the area resisting the shear? Pi d t. If you are given with radius, then it is going to be 2 pi r into t. 2 pi r into t. So the area resisting the shear force is given by circumference of the hole and the thickness of hole. So force required is given by pi d into t and ultimate shear stress. This is going to be the formula. This is going to be the formula to determine the force required to punch a hole. Steel punch worked on to compressive stress. Steel punch worked on to compressive stress. The force required is given by area into compressive stress. Area into compressive stress. What is a compressive stress? A compressive stress is induced inside the material because of the applied compressive force. What is a compressive force? You imagine an object is subjected to axial pushes. This force is called as compressive force. The stress developed due to this applied force is called as compressive stress. So here the area is going to be pi by 4 d square only. Here the area is going to be pi by 4 d square. So force required to punch a plate due to the compressive stress is given by F is equal to pi by 4 d square into compressive stress. Now we can solve a problem. If the ultimate shear stress of mild steel is 300 Newton per mm square, 300 Newton per mm square, fine. The force required to punch a 13 mm diameter hole in a mild steel plate of 10 mm thickness. Calculate the compressive stress in the punch. If the ultimate shear stress of mild steel is given, ultimate shear stress is 300 Newton per mm square. Ultimate shear stress is given as 300 Newton per mm square. Okay, we got to find the force required to punch a hole. Then second one is diameter of the hole is given 13 mm diameter hole. Thickness is also given, plate thickness is 10 mm. Then second we got to find the compressive stress in the punch. So simply by substituting these values in the formula, what is the formula? Force required to punch a hole, F is given by area resisting and ultimate shear stress. What is area? Pi d t into ultimate stress. So we know the value of pi, it is a constant, d is given, t is given, stress is given. So we can substitute all the values, we can find the force in terms of Newton. Similarly, for the second value, what is the compressive stress in the punch? Okay, we can directly substitute the values. What is force? Force required is equal to area into compressive stress. From this we can calculate the compressive stress as force by area. What is area? Area is equal to pi by 4 d square. So we can determine the value of compressive stress is 923.07 Newton per mm square. Now we can summarize the results. Force is equal to 122.522.1135 Newton. This can be represented in terms of kilonewton also. We can represent them in terms of kilonewton. Since it is a larger value, big value, very difficult to handle this value. Since it is going to be the answer, we can write it as 122.5 kilonewton. 122.5 kilonewton, and the compressive stress is given by 923.7 Newton per mm square. I hope you understand the problem. In the second problem, a steel punch can be worked onto a compressive stress of 800 Newton per mm square. Here the compressive stress is given. Find the least diameter of the hole. Find the least diameter of the hole which can be punched through a steel plate of 23 mm thickness. If the ultimate shear stress for the plate material is 300 Newton per mm square. So the compressive shear stress is given as 800 Newton per mm square, and the plate thickness is given as 23 mm. Ultimate shear stress is given as 300 Newton per mm square. What we got to find? We got to find the least diameter, minimum possible diameter of the hole that can be punched on the steel plate. Okay. So now we got to find the force required to punch the plate, the force required to, now we are going to find the force required to punch the hole in the plate due to shear stress. Fs is given by area resisting the shear stress multiplied by ultimate shear stress. What is the shear stress? Area pi into d into t into ultimate shear stress is sigma s. This is going to be the force, shear force required to punch the hole in the plate. It is given by this value. We don't know the value of d because we are going to find the value of d. So you keep d as it is. Now we will get the equation in terms of d. We can get the equation in terms of d. Fs is equal to 6900 pi into d. Now we are given with another compressive stress value. Now we can calculate the force required to punch the hole due to compressive stress. Okay. Fc is given by area resisting the compressive load into compressive stress. This is given by, what is the area? Pi by 4 d square into sigma c. This is going to be Fc. So we can keep the diameter value as it is and we will end up with the equation. Fs is equal to 200 pi into d square. 200 pi into d square. Now by comparing the two equations, because both the equations are required to make the hole in the circular plate or the steel plate. So we are going to compare the two equations. 200 pi d square, 200 pi into d square is equal to 6900 pi into d. Okay, we can cancel the terms pi in the two equations. So 200d is equal to 6900. From this we can determine the value of d as 34.5 mm. 34.5 mm. Okay. Sometimes we can round the value as d is equal to 35 mm. If it is required means we can round the value as 35 mm. But what is asked in the question? Okay, what is asked in the question? We got to determine the least diameter of the hole. So the least diameter of the hole that can be punched in the plate will be 34.5 mm. So the least diameter of the hole that can be punched in the plate is 34.5 mm. 34.5 mm. So with this we are coming to the end of the session. In this session we solved problems related to the mechanical properties of materials. First we solved problems related to stress and strain and to how to determine the elongation. Then we solved some problems using factor of safety. Then we learnt how much force is required to make a hole in a plate. Then we solved 2 problems related to the punching of hole in a plate. So, with this we are coming to the end of the session. We will meet in the next session. Thank you.